Now, good day. This solution to differential equation using Laplace transform. So what you need to know here is that you know the Laplace transform of the y dt, which is y prime and y prime, or you write it y dot. So what you need to know here, this is the equation for the Laplace transform and so on like that. So what you need to know here, the Laplace transform of the y dt is s. This one is the first derivative. That's why you write s. You see this one as s raised to power 1 y bar minus s raised to power 0 y naught. So you know s raised to power 0 is the same thing as 1. That's why it's not appearing here. So the second derivative now, you see this one, the power is what? Is 2. It means you start from s raised to power 2 y bar. The s will be decreasing like that, and the y will be increasing. The subscript of the y will be increasing. So the superscript of s will be what? Decreasing. This one is the second derivative, which is power 2. Now say s raised to power 2 y bar minus s raised to power 1 y naught minus s raised to power 0 y1. You know raised to power 0 is 1, that's why it's not appearing. So for third derivative, the same thing like that. Follow this trend like this. This one is power 3. This means you start from s raised to power 3 y bar minus s raised to power 2 y naught minus s raised to power 1 y1 minus s raised to power 0 y2. So, and Laplace transform of y is what? Y bar, or you write it y of s. But for this one now, we'll be using y bar. So example 1 now. Example 1 is solve using Laplace transform dy dt minus 2y equals to 4. Given that at t equals to 0, y equals to 1. So, and this your y equals to 1. What you need to know here is that this y equals to 1 is what means your y naught in the Laplace transform. It's your y naught in this Laplace transform. When you transform that differential equation here, transform the differential equation to Laplace transform, this will be your y naught. So now the solution is this: the y dt minus 2y equals to 4. At t equals to 0, y equals to 1. So the first thing you need to do is what? To transform this equation. Is differential equation here. So the first thing you need to do is to transform this differential equation to Laplace transform. Transform it to Laplace. So to transform this, we already I say from here now we already know the transformation of the y dt. So the transformation of the y dt at the other side is what? S raised to power 1, because this one is first derivative. That's why we say s raised to power 1 y bar minus s raised to power 0 y naught. So you don't need to write s raised to power 0 there. It's 1 already. So that's for this transformation of the y dt. Laplace transform of this now, this y a is what? Is y bar. Just write this 2 is like constant. So 2y bar equals to Laplace transform of this 4 is what? 4 over s from Laplace transform. So you can check that from Laplace transform is what? 4 over s. Laplace transform of a constant, and Laplace transform of a equals to a over s. So it's the same thing as 4 over 5 over s. So now the next step, the first step is what? To transform the equation. The next step is to what? To substitute the value of t equal to 0 and y equals to 1. And you know I said why this y represents y naught. So you now say anywhere that you see y naught from in your equation like this, you substitute with y equals to 1. So it means sy bar minus y equals to 1 is y naught 1 minus 2y bar equals to 4 over s. So the next thing, what we're now trying to do is what? To make this y bar as the subject of the formula. You make this y bar as the subject of the formula. Any way that you can pass to make this y as your subject of the formula. That's what we are trying to do now. So we now do what? We collect the like terms. Sy bar, this one has y bar and this one also has y bar. So we now what? Collect the like terms. The one that has y bar, bring them together, and this one you now move this one to the other side. And anytime you cross the boundary, this equal to is like a boundary. It's like you move from one country to another. So anytime you cross the boundary, you change your sign. your sign will change. So this one moves to this side. That's why you see 4 over s plus 1. So it's negative here and it's changed to what? Positive. So we now collect the like terms here. The like terms here is we have y bar here and y bar also here. Bring it out. It remains s minus 2. So equals to, you find the SM of this. It's not that 4 over 5 plus 4 over s plus 1. You now say one whole number 4 over s. No. You find the SCM. You see this one as 1 over 1. So when you find the SCM of s and 1 is s. So find it. How many s in s? 1. 1 times sy bar, sy. This one has y bar and this one also has y bar. So we now what? Collect the like terms. The one that has y bar, bring them together. And this one, you now move this one to the other side. And anytime you cross the boundary, this equal to is like a boundary. It's like you move from one country to another. So anytime you cross the boundary, you change your sign. Your sign will change. So this one moves to this side. That's why you see 4 over s plus 1. So it's negative here and it's changed to what? Positive. So we now collect the like terms here. The like terms here is we have y bar here and y bar also here. Bring it out. It remains s minus 2. So equals to, you find the SM of this. It's not that 4 over 5 plus 4 over s plus 1. You now say one whole number 4 over s. No. You find the SCM. You see this one as 1 over 1. So when you find the SCM of s and 1 is s. So find it. How many s in s? 1. 1 times 4, 4. Plus, how many 1 in s? S times 1, s. So after the SCM, this is what you have. You know, I said you are looking for this. You want to bring this y outside and make it as subject of the formula for others now. So we now say your y bar. The only thing remains here is y bar s bracket s minus 2. You now do what? Y bar. You can divide both sides by s minus 2. So this one we cancel this. Or you write it, you cross multiply like that. This y bar, bring this one down to this side. It will now be s bracket s minus 2 separately. When you reach this line like this, so you know that the next thing is for you to do what? According to the Laplace transform we've been doing since. So the next thing you need to do is what? You look at it whether it allow you to use partial fraction or not. So this, you follow all the steps for partial fraction to confirm whether you can use partial fraction for it or not. So the first thing you need to check is what? To check whether if the denominator, the power of the denominator is greater than the numerator. So when you expand this bracket now, you see this one is s squared and it's greater than this one. This one is s power 1. So it means it was, you can use partial fraction. And the second thing is you check whether this one is what? Is factorizable or everything like that. So the next thing you need to do, use partial fraction. To use partial fraction now, you know this one is according to the law of partial fraction like that. You know, when you have something like this, you can easily split it. This one go for A and the other one go for B, according to the law of partial fraction. So you now use partial fraction for it. S plus 4 over s bracket s minus 2 equals to A over s, this first s, and plus b over the second one. So next thing for you is to find the SCM of these two. When you find the SCM of these two, you get this s bracket, this just multiply it is the SCM. This is the SCM of the two, and the SCM we cancel the SCM of this side, so it remains s plus 4 equals to A bracket. When you find the SCM like this as s bracket s minus 2, you know, when you say how many s do we find is this SCM, s we cancel here, it remains s minus 2. S minus 2 multiplied by A. That's why you have A bracket s minus 2 plus, when you say how many of these are you see in this, s minus 2 cancel s minus 2, it remains s multiplied by b, bs. So we now look for, now this is the remaining equation. Now you now look for what can you do to eliminate one. If you want to get A first, you look for anything you can do that you can use to eliminate this b. Is that when you let s, your s be 0 like this, you can easily eliminate b. So we now say let s equal to 0. So it means when your s equal to 0, you substitute 0 for anywhere that you see s like this, you substitute with 0. It will now be 0 plus 4 equals to A bracket 0 minus 2 plus b 0. And you know this times 0 is what? Is 0. It will now be 4 equals to minus 2a plus 0. So 4 equals to minus 2a. Divide both sides by minus 2. You get your a equal to 4 over minus 2. That will be your a is minus 2. The next thing you need to do is look for a way to eliminate this a. The only way you can eliminate a is that you find any number that you can use to subtract. You can use to substitute this s to make everything here equal to 0. So is that you find positive 2. If you say 2 minus 2 like this, 2 minus 2 will give you 0. And when you multiply this 0 by a, everything will turn to 0. So it means you say let your s equals to 2. So let s equal to 2. After that s equals to 2 like that, it means what? 2, you start from the beginning, from the left side. 2 plus 4 equals to a bracket 2 minus 2 plus b bracket 2. So everything here is 0. Now say 6 is equal to 0 plus 2b. 0 plus 2b. So and your b, you get it, everything 6 is equal to 2b. Divide both sides by 2. Your b equals to 3. So after you've gotten the value for both a and b from your partial fraction like this, you now do what? You replace it. You replace it as what? Your y bar equals to, from the beginning here, your y bar equals to this, equal to ab. Your a is now minus 2 and your b is 3. You replace it. After replacing it, the next thing for you is to do what? To get half at the top of your SCM at this side. So it will now be 6s minus 8 equals to a multiplied by this and plus b multiplied by the other side after you've gotten the SCM. So you now find a way to eliminate this b to get the value of a. To eliminate, you find a way to eliminate is that you find something that will make this thing inside the bracket s plus 2. What can you use to represent this s to make this one is 0? So you find it when let s equal to minus 2. When s equal to minus 2, it means this one will turn to 0. It means everything here is 0. So you get the value of this a from that. So your a will be what? Your a will be 12 minus 8 minus 5a plus 0. Now minus 12 minus 8 will give you minus 20. But minus 5a is this. So divide both sides by minus 5. So minus 5 cancel minus 5. Minus 20 over minus 5. Minus cancel minus 20 over 5 is 4. Your a is 4. The next thing is to find how you can eliminate this a to get the value of b. So to eliminate this a, a is what? A bracket s minus 3. So do you know that to eliminate this a, you find the number that you can use to subtract this number that will make everything 0 is 3. You now say let s equal to 3. So everything here, you get it. You find the value. You get your b out of it. When you get b, it means your y bar equals to this. So get the value of this b from this. So when you get your b, the next you now substitute the value of our a and b to that equation that you got there from your partial fraction that you get. So it will now be y bar equals to this. This everything here is equal to this. This means it's the same thing. So you now say this one is in y bar and we are looking for y. To get y, it means since our Laplace transform of y gives us y bar, it means when you find the Laplace inverse of this y bar, you get y back. So we are looking for our y. So to get this y now, you now say Laplace inverse of this y bar equals to y equals to Laplace inverse of this and Laplace inverse of this. So to get the Laplace inverse of this, it means it's what? You already know that the Laplace transform is what? For you bring this 4 outside like this, it will not be 4 Laplace inverse of 1 over s plus 2 plus 2 Laplace inverse of 1 over s minus 3. And you know Laplace inverse of 1 over s plus 2 is exponential minus 2t. And the 4 that is already outside, you get 4 exponential minus 2t. And this one, 2 is outside already. This is the 2. The next one is exponential 1 over Laplace. Which Laplace inverse will give us 1 over s minus 3 is what? Is Laplace inverse, Laplace transform of exponential 3t will give you 1 over s minus 3. So that will be your answer. That's all. So now after you've gotten the value for a here and b, so the next thing it will now be y bar equals to s plus 4 over s bracket s minus 2, which is this thing now equals to everything here. It means this and this are the same. So it means your y bar now equals to this. You now find the, everything here is in Laplace transform. You now find the Laplace inverse of this y bar. It will now be Laplace inverse of y bar equals to y, because the Laplace transform of y is y bar. So Laplace transform of y is y bar. So inverse will now be Laplace inverse of y bar equals to y, equals to everything here. You now give it Laplace transform of this, Laplace transform of this separately. So after that, the next thing to do is what? Y, the Laplace transform of this that we did here. Laplace transform of, that Laplace transform of constant, like Laplace transform of a equals to a over s. So Laplace transform of 2 will give you 2 over s. Laplace transform of minus 2 will give you minus 2 over s. So it means Laplace inverse of this will be 2, will be minus 2 of this. And Laplace transform of 3 over s minus 2 is like you bring this 3 out like this, be like 3 Laplace inverse of 1 over s minus 2. And 1 over s minus 2 is exponential 2t. It will now be minus 2 plus 3 multiplied by exponential 2t. So your answer will now be what? Your answer will be y equals to minus 2 plus 3 exponential 2t. That's the final answer. Another example, solve the y dt plus 2y equals to 10 exponential 3t, given that t equals to 0 and y equals to 6. The solution is that you already know that the first step is to transform this equation now. You transform it to what? Laplace transform now. Change it to Laplace transform. This is Laplace transform of this equation, dy ds. Laplace transform of dy ds is sy bar minus y naught. That's for dy ds. Dy dt is for dy dt plus Laplace transform of this y is what? Y bar. That's why you see 2y bar plus Laplace transform of this one now. You bring this 10 aside. You now find Laplace transform of exponential 3t. And the Laplace transform of exponential 3t is 1 over s minus 3. So it will now be this 10 that you bring separate aside. You now use that 10 to multiply the 1 at the top of 1 over s minus 3. It will now give you 10 over s minus 3. So the next thing for you is to substitute your y equals to t, which means, I said y, this y represents y naught. So we now bring it here. So anywhere that you see y naught in this equation, you substitute with 6. It will now be sy bar minus 6 plus 2y bar equals to 10 over s minus 3. Here, y bar equals y bar, collect the like terms. We have y bar here, we have y bar here. Just bring that y bar outside, because you want to use this y bar as your subject of the formula. So you find a way to make it as your subject of the formula. It will now be y bar bracket s minus 2 when you collect the like terms. So equals to this minus 6, bring it to this side as 6 over 1, and you find the SCM here. Don't just add it, you find the SCM, and the SCM will be s minus 3. You get it? So s minus 3. After that, this is what you get from the SCM, and your y bar bracket s plus 2 equals to this. So after you gotten this, you know that the next thing you are looking for this y bar. So bring this one down here. It's as if you divide both sides by s plus 2. S plus 2 we cancel s plus 2, it remains y bar. And this one will be now what? 6s minus 8 over s plus 2 here that we used to divide both sides. And s minus 3 that is there already before. So the next thing was you find the, when you see it like this, the next thing is to do is a partial fraction. To find the partial fraction of this, use partial fraction to solve it. So it should now be y bar equals to 6s minus 8 over s plus 2, s minus 3. So it will now be equals to a over s plus 2. You can use a over s minus 3. You can use anyone. You get the same thing. A over s plus 2 plus b over s minus 3. Find the SCM. It's compulsory that you find the SCM of the two. The SCM will be the product of the two like this. So the next thing, SCM here, we cancel the SCM here. So it will remain the numerator here and the what you have at the top of your SCM at this side. So it will now be 6s minus 8 equals to a multiplied by this and plus b multiplied by the other side after you've gotten the SCM. So you now find a way to eliminate this b to get the value of a. To eliminate, you find a way to eliminate is that you find something that will make this thing inside the bracket s plus 2. What can you use to represent this s to make this one is 0? So you find it, when let s equal to minus 2. When s equal to minus 2, it means this one is turned to 0. It means everything here is 0. So you get the value of this a from that. So your a will be what? Your a will be 12 minus 8 minus 5a plus 0. Now minus 12 minus 8 will give you minus 20. But minus 5a is this. So divide both sides by minus 5. So minus 5 cancel minus 5. Minus 20 over minus 5. Minus cancel minus 20 over 5 is 4. Your a is 4. The next